So chapter 4, lesson 2, comparing and ordering rational numbers. The first thing I have to do is I have to explain what a rational number is. Because sometimes we hear the word rational, we don't really know what it means. Rational means any number you can make into a fraction. So today, in our lesson, we're going to talk about decimals, because you can make decimals to fractions. We're going to talk about regular fractions, and we're going to talk about percents, because you can actually make percents to fractions and decimals as well. So we're going to be dealing with pretty much those three things today. So before we get started, I kind of just want to talk about, because we did this the other day in class, yesterday, for some of you, 2 days for a few of you. How would I make 0.44 into a fraction? What would that look like? Mason? 44 over 100. How do I know what my number underneath is going to be? How do I know? Do I just guess? Like, I think today I'm going to put over 10. Yeah, how do I know? Bella? Place value. Very good. See where my 44 ends? Ends in the hundredth spot. That's what number I'm going to put underneath. So if I look at this number, what number, 0.1, what number am I going to put underneath that? Tens. Yep. What about this one? Thousand. So it'd be 622,000 over 1,000 you can reduce. Okay? You're going to have to remember this because this is part of your assignment today, is remembering how to do these things. That's the thing about math, believe it or not. Like if you learn it one day, they expect you to know it for the next day. Like, believe it or not, it builds off top of each other. So you kind of have to remember what we did in the past. First thing you have to write in your notebook is this: comparing decimals. Because we're going to compare a lot of things today. We're going to compare decimals, we're going to compare fractions, and we're going to compare a whole bunch of different types of numbers. So comparing two decimals is the first thing we're going to talk about. If you're like me, you like to have steps. Like you want to know step 1, what do I do? Step 2, what do I do? So step 1, when you compare decimals, you're going to put them on top of each other. That's step 1 when you're comparing two decimals. Okay, step 2 is compare the numbers from left to right. Okay. So first you're going to line them up, put them on top of each other. Second, you're going to look at the place values from left to right. And what I mean by compare is telling which one's greater. When we're comparing two things, we're probably looking at seeing which one's greater. All right, so how does this work? First thing I want you to do is I want you to put these two in your notebook, okay? Because we're going to compare those two. I'm just going to show you with a simple one how it works. I'm going to get to some harder ones in a second. So we're going to compare those two, 2.457, 2.458. I did step 1 already for you. I put them on top of each other, okay? And you have to line up the place values. Like if you are lining up different place values, you're never going to have the correct answer. Then what I'm going to do is I'm going to look from left to right. And I'm going to start here and I'm going to say, oh, okay, are these two the same number? Oh, so I can't really use that to compare. Same number here? Yes. Same number here? Yes. What about this place value? No, they're not the same. Which one has a higher number? The 8. So that means that this number here is the bigger decimal. Many times people think decimals, if they have, like, here's an example. This one right here. What do you think a lot of people would think the bigger decimal is here? Not necessarily. A lot of people would automatically assume this is the bigger decimal just because there's more numbers to it. People automatically assume because there's more digits, the decimal is always bigger. Sometimes it's true, sometimes it's not. Yep. Technically on this one, the first one is what? 34.9. I'm going to line them up. 34.981. What could I put here to help myself out? I can put some zeros, yep. So if I go through my place value, well, same, not the same. So which one is technically bigger here? Even though there's more digits for that one, it's bigger just by the place value. That doesn't always work that way. Let me give you an example. Okay? So let's say I have 7.6421, and then I have 7.65. 0, 0 if I want to finish it out. Many people would assume the top one's bigger because there's more numbers. Not always true. Which one is the bigger one though, Isabella? Yeah, 7.65. Same. Oh, not same. This one's bigger. Okay? That's how you compare decimals. You guys have any questions on that? I mean comparing, what I mean by finding which is greater. That's what I mean by comparing. So, questions on that? Okay? Next thing I'm going to do is we're going to talk about comparing fractions. So in your notebook, you need to write comparing fractions. Hope you took something about comparing decimals. One vocabulary word that I'm going to use is denominator, common denominator. A common denominator is when you have the same number on the bottom of a fraction. Common denominators when you have the same number in the bottom of the fraction. A lot of times when you're young, they talk about the least common denominator. That's maybe something you heard, or LCD. Anybody remember that? LCD, least common denominator. When you compare fractions, you technically don't have to have the least common denominator. As long as you have a denominator that's common, it doesn't matter. So here's some steps to comparing fractions. So before I gave you some steps for decimals, I'm going to give you steps here. So the first step is to have common denominators. Okay, the second step is to look at the numerator. I'm going to say, can I say the top number? You guys okay with that instead of numerator? Top number to compare. Okay, so the first you're going to have to have common denominators. And sometimes they might already be common for you and you don't have to change anything. But the second part is you have to look at the top number then to figure out which one's bigger. I feel like you guys are always good at fractions. Like, you must do fractions a lot in 7th or 6th grade. Like, is that like your whole book is fractions? Because I feel like it is. All right, so here's a short, sweet example. I have two fractions. I have 436 and 936. I have common denominators. Okay, check one, done. Have common denominators. 2, look at the top number. I have a 4 and a 9. Which one's going to be greater than? Matt? The 9. So the 936, you can, in your book today, it's going to have you do the, you know those things? What are those things called? Remember those? Remember alligators? We talked about a little bit the other day. Bigger side goes to the bigger number. Yep. Yep. Now let's talk about, does anybody still need this yet? Okay. Okay. I'll wait a few seconds. No, I was just talking about that these are common denominators already. The next slide, I'm going to talk about some that aren't common, if we're going to remember how to make them common again. Good? All right, so here's some fractions. We're going to look at these two, and our job is to compare them. How do you make common denominators? There's a lot of ways to make common denominators. I have a 5 and a 6. What can I do to make them common, Matt? Don't remember. Does anybody remember what to do? There's a few different things you can do. Landon? Basically change them. Okay, but how do I change them? And what do I change them to? Yeah. I can't really reduce. I have to have common denominators to compare them, though. So I can't really reduce in this case because I can't really reduce this. If I reduce it, it gives me 1/2. I can't reduce that. Is that common denominators? No. 5 and 6. What can I do? Two ways. There's two ways. You got a way, Matt?
You change them both the bottoms to 30, and then you take them.
Okay, so time out. How did you get 30? Where did 30 just appear from, Matt?
You take 5 times 6.
Okay, so one way you can find common denominators is take the bottom two times each other. Another way is to say, okay, what are my multiples of 5? 5, 10, 15, 20, 25, 30. 6 is 6, 12, 18, 24, 30. Oh, look, 30 can be a common denominator. Some of them you'll know off the top of your head what they share. Sometimes you will, sometimes you won't. So I'm going to use 30. And the reason why, they didn't really share anything, so I multiply them together, it makes them share something. Now, this is how I do this, okay? I don't know what you were taught last year, but this is how I do it. I create two whole new fractions belowhand, okay? And then I say to myself, what did I take times 5 to get to 30? Okay? I have to do the same thing up here. I have to take 4 times 6 then, which gives me 24. On this side, what did I take times 6 to get to 30? Okay? Then I have to take 3 also times 5, and I get two common denominators now. Okay? Which one's greater? Now I have my common denominators, check. I have to look at my numerators, Mason. So it's going to technically look like this. That makes sense to everybody? See why? Yep, go ahead. Well, in your book, it's going to give you these two things, and it's going to look like this. It's going to have the circle in between. So down here, you need to do the math to figure out which one's greater than, and then you do the sign in the middle. Okay? Mason. Where? Take it times 5, though. So this over here? No, this is 5, this one? Yeah. Yeah. This is 5. Yeah, I know. It's supposed to be times 5. Because if I take 6 times 5 to give me 30, I have to take 3 times the same number, and that's what 15, where 15 comes from. Okay? So I just use this to show myself what I have to multiply by. Okay, so let's do another. Fair enough? Let's do another. Let's go to this one. 4 12s and 3 4s. Now there's a whole bunch of numbers I could use for a denominator here. Anybody have one they want to throw out? Owen? I can keep 12. Why can I keep 12? Does 4 go into 12 evenly? Yeah. Sure. Could I multiply 12 and 4 to find a common denominator just like what we did before? Sure, it doesn't matter. I don't care what the lowest one is. It doesn't matter because you're just comparing. So let's keep 12. So I don't have to do anything here. But I do have to do something here. Now, what did I do to 4 to get to 12? Times by? Okay, so what do I have to do to this 3 then? Times by 3, so, which is going to be 9 here. So which one's bigger? 3 over 4 is technically bigger, because now looking here, well, this one's bigger, so it's going to look like this. Okay? Yep. Okay. Why don't you try a few yourself? Okay. Now, most of these in here, one of them doesn't have to be changed. Okay, I made it easy, so you don't have to change both denominators. There's just one of them technically that has to be changed. Okay, so do them on your notebook, see what you can remember, see if you can try it by yourself. Try 4, so I'll label them. This is number 1, this can be 2, 3, 4. Okay, so you try them by yourself. They only, technically, one of them really just needs to be changed in all of them. You try. Ready to give it a whirl? Which one are you on, Isabel? Okay. I'll give you a few seconds. All right, you ready? Okay. Number 1, you probably kept 18 over 24. What did you change this to then? What did you change this to, Matt?
20 over 24.
Okay, so first you need 24. 6 times 4 is 24. So you have to take 5 times 4, which is 20. Comparing the two, which one's greater? Should go this way. Okay, let's do number 2. You probably kept this one. What did you change this one to? What does this one look like now? So 36 times 4, right? So take that times 4, that's got to be 16. Greater should go this way. Up on top, you probably kept 25 over 19. This is got to become a 25 times 5. Times 5 would be 20. Should look like that. And then the bottom here, you probably kept 30 and made this 30 times 3. This would be 21. Should look like this. Okay, fair enough? Good. Everybody remember how to do this? Okay, let's go to sum with negatives now. Let's go to sum with negatives now. Make sure you put some of this in your notebook because there's sum with negatives in your homework today. I'm going to compare these two now. So the same rules goes. I have to make a common denominator. I'm going to worry about the negative in a second. Make your common denominator. So what can I use for a common denominator here? What could I use? Mason? Yep. So this one's going to stay. This one's got to change. Times 3 times 3. So this would be a 9. And now I have a negative there. Everybody see how I did that? I just changed denominators. I brought my negative with it. Now the thing about negative fractions is that, do you have a question? Just let me talk. Maybe it'll answer your question. Negatives with fractions can float. They can float to the top number and they can float to the bottom number. Okay? So if I would float it to the bottom number, it's really not going to do anything for me. What I need to do is I need to float it to the top number. So this would be -9, and this would be -10. Now you have to think about what we did last chapter. What's greater, -9 or -10? -9 is greater. You got to think about what we did. -9, or what? Another way to think about what's colder. The one that's colder is always smaller. So what is technically bigger here? Yes, so technically it should go like this. Does that make sense? All right, I'll do another one for you. You try this one by yourself. You try this one by yourself. Let's do -4 6 and -3 8. There's a lot of denominators you could use here. Just 24. You could use 48. Is there anything in between there? Nope, not 32. So regardless of what you used, we should still have hopefully the same answer. That's the key. Who used 24 as a denominator? Who used 48? Okay, I'm going to use 24 just because I know 8 and 6 go into 24. Sorry. Yes, they do. 6 times 4 is 24. 4 times 4 is 16. Okay. This times 3 is 24. This times 3 is 9. This is what they look like now. So I have a negative 16 on the top and a negative 9. Which one is greater now, Matt?
9.
That's what it should look like. That's what it should look like. Yes, if you did 48, it should still be the same way. It doesn't matter what denominator you use. It's going to still tell you which one's bigger. Doesn't matter. Okay? Any questions? Let me do one more of these. Let me do one more. And I'm going to do whole numbers. So let's say we have 2 and 2/3, negative 2 and 2/3, and negative 2 and, let's see, 5/6. Okay? Got to change denominators. I already have a denominator I can use. Do I have a denominator I can use? Yeah. 6. It's already up there. Could I use 18? Sure, if I wanted to, but I already have one. So I'm going to keep this. Negative 2 and 5/6. This is going to be negative 2. Let's see, 6 times 2 times 2 is be 4. Now, don't let this one confuse you. You still need to look at the top number, but remember it's negative. So what is going to be greater here, Landon? You're correct. You're right. You're right. Okay? Any questions? Questions on that? All right, almost done. Next thing in your notebook, percents to decimals. This is the next thing in your notebook. This is very easy. Did you need the other side? Did you need this one yet?
No, I'm good.
You can turn your page and have more notes. Some days you have more notes. Turn your page. Turn your page. It's okay to turn your page. Okay, percents to decimals. Question? No. I did fractions to decimals, but I didn't do percents. I did. You're right. But this is kind of backwards, yeah. So let's say, so percents to decimals. Here's your steps. Number 1, find decimal, which is very easy. Number 2, move decimal left 2 spaces. So I'm just going backwards of how I taught you to find your grade. All right, so I have 45%. Where is your decimal at in a whole number usually? Yeah. If I have a whole number, where's the decimal usually at? If I have like 11, yeah, where's the decimal usually at? It's after the number, right? So the same thing happens here. If I have a whole number, here's my decimal. We just don't put it there. Okay? Now what's my next step? 2 spaces like this. 1, 2. 45% is 0.45 in a decimal. That's it. The end. Yeah, it's super simple.
So it's technically like grading.
It's like grading. So like it's let's say you did your grade and you came up with this. How do you make it a percent then? Move it over 2 spaces to the right. Right. It's just the opposite of what we talked about for your grades. So if you have 23%, where's the decimal at? After the 3. 2 spaces. This is what it looks like. And as soon as you move that decimal, that percent sign goes away. Yep.
So what if the dot is before, would that mean have that on our,
Like this?
no, like, you know, remember like 23?
Mm-hmm.
And it's before that, you need to.
No, you always, if you're making a percent, a decimal, you always move it to the left. Always. Is before, then you can change it, move it to percent, sure, if you want to. But you won't have to do that today in your homework. Okay? Landon? Yes. Yes. So if I have a decimal in my percent already, what do I got to do? Go where that decimal is, move it 2 spaces over, and it's this. Make sure you have this example in your notebook or something because you're going to get to it in your homework today and be like, I don't remember why we did that. So make sure you have something in your notebook. Another question somebody else asked me from the other class is, what if you have like 115%? What's that in a decimal? Yeah, this is what it would be. Because your decimal's here, move it 2 spaces, that's what it would be. Okay? Pretty simple, right? Pretty simple.
Wait, you don't have to have that third one.
This one?
Oh, that's the percent sign.
That's my percent. I'm sorry. There we go. All right, so easy to make percents decimals and decimals to percent. Yeah, we didn't talk about making decimals into percents yet, but that's another day, okay? And you already know how to do it anyway. So here's what they're going to ask you to do today. They're going to ask you to order these things from least to greatest. Now it's very simple because you've learned it all already. The easiest thing to do is to change them all to decimals. Do you know how to change a percent to a decimal? You just did it. How do you make a fraction a decimal, though? We talked about this 2 days ago. How do you make a fraction a decimal? This is what you did in your homework. How do you make a fraction a decimal? Anybody remember? Daily. Divide. That's it. All right, so let's do this. In your notebook, write this in there. Write this in there. We're going to order these from least to greatest. And the easiest thing to do is changing them all to decimals because you know how to do all of that now. So we're going to order 23%, 0.21, 1/4, and 1/5 all to decimals. So this is what I do. I usually just go down the line and I say, okay, what's this in a decimal? 0.23. Remember, 2 spaces. Done. This is already a decimal. Sweet, don't have to do anything with that. 1/4. You probably know it off the top of your head already, 0.25, but if you don't know, you would take 1 divided by 4. Remember? Remember that? Okay. 0.25. Same thing here. How am I going to change that? I'm going to do the same thing, 1 divided by 5, and actually, it's 0.2. I'm going to put a 0 on the back also. Yep.
So it's less than.
Yes. Because remember the first time we compared them, we put them on top of each other like this, and we said, okay, which is this one's, yep, you're right, because we already talked about it. Okay, so now we got to put them in order from least to greatest. Now they want you to put them in order that they have in the book, not the decimal. So if I look up here, what's the smallest thing up here? What's the smallest thing, Isabella? Nope. That's not the smallest. 0.20, right? 0.20. Remember, go back to the first page we did, order them, think of what's greater. Smallest thing is this. So this is how you would list it, 1/5, because they want you to list them in what they have as the format. Now what's the smallest? Yep, so 0.21. Now what's the smallest? 23%. Now what's the smallest? I think it's 1/4. Or the greatest, I guess I should say. So it looks like this. Okay, do you understand what I did there? I made them all decimals. Then I could figure out which one was greater and less than, and then I used this format to order them from least to greatest. Yes? You have to use that format? Yes. Yep, yep. All right, I'm going to give you another one. You try by yourself. Ready? Ready? Last thing. Last thing. All right. 70% is the first thing. 0.62, 3/4, and 66%. Order those least to greatest. Yeah, they usually don't trick you. It's always usually least to greatest in our book. Least to greatest. Question or you know the answer? Okay, 1 second. Let's everybody work a second. Easiest thing to do, make them all decimals. Because if you made them all fractions, then you'd have to mess with a lot of denominators. That would be horrible. So decimal is the easiest way to order them. right, so first thing I'm going to do is I'm going to go through and make them all decimals. 70% of the decimal looks like what? 0.70. This is already it. 3/4 in the decimal?
9, 12.
What? What is it, Owen? 0.75. What are you talking about? And then this in a decimal would be 0.66. Remember, if you don't know how to make this a decimal, 3 divided by 4. This is what it looks like. Okay. Now, what's the smallest decimal up here? What's the smallest one, Matt?
0.66.
Nope. It's the smallest one. Nolan? 0.62. This one's the smallest. Then, Matt, it would be 66%. Then what's it going to be? 70%. Then it's going to be 3/4. That's how it should look like. Any questions for me? Greatest, you did greatest. We want least to greatest all the time. It's always going to tell you what it wants, and for the most part, it always wants least to greatest, smallest to biggest, okay? All right, I need you to get your book out, because I'm going to talk about your homework.